Hello student, welcome to the class. So in the last class we discussed about the frame of reference, isn't it? And in the today's class we are going to discuss about the types of the frame of reference and the Galilean transformation equation. So let's go to the first thing, that is the types of the frame of reference. So as in the last class what we discussed is the frame of reference. A frame of reference is nothing but, suppose any body is there, the body is there. If you want to define the position of a body, if you want to specify the position of a body, then something coordinate system you are using, isn't it? So that coordinate systems are nothing but x axis, y axis and the z axis, which are perpendicular to each other. So such a type of system we are using. By the help of this system we will define the position is equal to x comma y comma z, isn't it? And this system is called as what? Frame of reference. So frame of reference is nothing but a body in rest or a body in motion can be located with the help of a certain coordinate system. With the help of some coordinate system, that is called as what? The frame of reference. And that coordinate system is nothing but the Cartesian coordinate system, which is using familiar. It is so familiar to use the what? To represent the frame of reference, which contains the x-axis, y-axis and the z-axis, and all these axes are perpendicular to each other. Now we are moving, what will be the types of the frame of reference? So there are two types of frame of references are there. One is the inertial frame of reference. The first one is nothing but the inertial frame of reference, and the second one is non-inertial frame of reference. Non-inertial frame of reference. So there are two types of frame of references are there. One is the inertial frame of reference. Second one is the non-inertial frame of reference. So let's go to the what? The first thing, that is the inertial frame of reference. Inertial frame of reference is one in which Newton's first law of motion is valid. So if a Newton's first law of motion is applied to any frame of reference, that type of frame of reference is called as what? Inertial frame of reference. So here Newton's first law of motion will be what? Valid. Then what will be the Newton's first law of the motion? So already we studied this all the thing. Newton's first law says that whenever a body is there, it will be at a rest position or it is moving with a uniform velocity unless an external force acts on it. So if a force acts on it, then it will start to move. Or already if it is moving with a uniform velocity, if a force applied, then it will change its what? Velocity. This is called as what? Newton's first law of motion. So according to this, if any frame of reference for this it is applied, then that is called as what? Inertial frame of reference. So as we know already, Newton's first law of motion is also called as what? Law of inertia. That's why the name is what? Inertial frame of reference. So one thing you keep in the mind, if a Newton's first law is valid to any frame of reference, so that is comes under which category? Inertial frame of reference. Then the question is, what will be the examples of the inertial frame of reference? Suppose one frame of reference is there. This is the frame of reference which contains x, y, z axis which are perpendicular to each other. Now at time is equal to 0 second, here it is the frame of reference is there. At t is equal to 1 second, the position will be same. At t is equal to 2 seconds, the position is same. Means any frame which is there at a rest position. So that's under the what? Inertial frame of reference. Or another frame of reference is there. So let it be x dash, y dash and z dash I will take, which is moving with the linear velocity. Means what? Uniform velocity. So it is at rest position and it is moving with how much velocity? V, which is linear, which is uniform. So if it is the case, then this frame is also comes under what? Inertial frame of reference, because it will not It will not change its position unless a force acts on it, and it will not change its velocity. Its velocity rate it will not change unless an external force acts on it. So these two comes under the word inertial frame of reference. So inertial frame of reference is one in which Newton's first law of motion is valid. The example is whenever the frame of reference is at a rest position, rest frame of reference, or a frame of reference which is moving with the velocity what v. So both comes under the inertial frame. And let's talk about the what non-inertial frame of reference, means opposite to the inertial. Here Newton's first law of motion does not valid. So if a Newton's first law of motion is not valid to any frame, that type of frame is called as what? Non-inertial, not applying. So it is what? Non-inertial frame of reference. So the frame in which Newton's first law of motion not valid is called as what? Non-inertial frame of reference. Then what will be the example? Suppose one frame is there, x, y, z, which is moving. As it is moving, it is having the velocity. But here this frame is not moving with the uniform velocity. At every second of the time, it is changing its velocity. Means can we say it is moving with the acceleration? Is it having the acceleration? So any frame is having the acceleration. That comes under the word non-inertial frame of reference, or a frame of reference which is rotating. Rotational frame of reference also comes under the word non-inertial, because every time it is changing its what? Velocity. That's why this is called as what? Non-inertial. So the best example for the non-inertial is a frame of reference which is having the acceleration and a rotational frame of reference. So both comes under the word non-inertial. So these are the two types of the frame of reference. Now we are moving to the next concept of this theory of relativity chapter, and that is nothing but Galilean transformation equation. That is nothing but what? The Galilean transformation equation. So already while explaining about the introduction of the theory of relativity, I explained two type of theory of relativity is there. One is the general theory of relativity, second one is the special theory of relativity. So whatever, Galilean is a scientist name. So Galilean, whatever he did the experiment, no, that is for general theory of relativity. And the special theory of relativity will be given by the what? Einstein. So Einstein gave the what? Special theory of relativity. So Galilean comes to the what? General theory of relativity. So let's talk about the Galilean transformation equation. So how he gave the equation for the theory of relativity. For this we need two frame of reference, isn't it? For that, the first frame I will take, let it be having the coordinates x, y and z. This is what the first frame of reference. Now the second frame I am taking, actually the second frame also contains three axes x, y, z, but initially they are coincident with each other. These two frame of references are coincident with each other when time is equal to 0 second. But as soon as the time will be running, the second frame of reference starts to move like this. Is it moving with a what? Certain velocity. So when it is moving after a certain time is equal to t second, it is reaching this position. So this is the position after a time is equal to how much? T second. So when time becomes t second, it is reaching to this position. Now can I name the coordinates are x dash, y dash and z dash, because the two frames are there, isn't it? That's why the first frame x, y, z, the second frame x dash, y dash and z dash. Now I am giving for this system the name is S, isn't it? This is the S frame and this is the S dash frame. Let's take two frame of reference. One is S, another is S dash. S is at a rest position and S dash frame is moving with a certain velocity. So as it is moving with a certain velocity, that velocity I will take it as a frame. like this frame is moving with how much velocity? V velocity it is moving. And second thing, when we will see the nature of the system, it is moving along the what? Positive direction of the x-axis. As it is moving in this direction, is it the positive direction of the x-axis? So it is moving with how much? It is moving along the positive direction of the x-axis. If it is moving like this, it is changing along the y-axis. If it is moving like this, it is going along the z-axis. But now it is changing only along the what? X-axis. There is no change along the y-axis and the z-axis. Only x-axis is going to what? Change. So let two frame of reference S and S dash. S is at rest position. S dash is moving with a velocity v meter per second along the positive direction of the x-axis. This is the first thing. Now, if it is the case, next what I am doing, something event is happening. Something event is happening in the space. For that, I will give the name P. So, for that, I am giving the name P. Event means what? It is the accident, it is the sound, it is giving the sound, or if I take the torch, it will start to give the light. That is also event. So anything you can consider the event. So if your eyes are blinking, that is also event. One type of event you are taking at a point P. It may be accident or it may be giving sound. If your eyes are blinking or any body is giving the light. So that is the event we are taking at the point P. Now, two observers are there. One is there in the S frame, another one is there on the S dash frame. So both the observers are observing this event. Here I am there and another person is there in the what? Another room. So both we are observing the same event, isn't it? So when we are observing that event, according to both the observers, whether the position of the event will be same or it will be different, isn't it? That calculation we are doing by using what? Galilean transformation equation. So to find this, first thing we should specify the position of the body. So let's specify the position of the body according to S frame as well as according to S dash frame. Let's talk about the S dash frame first, as it is there in the S dash. I can give the example here. Suppose you are standing on the earth. One bird is flying in the space and another person is there who is sitting in the aeroplane. So two observers are there. One is you, who you are standing on the earth. That is the first observer. Second observer is in the what? Aeroplane, isn't it? So the person who is standing on the earth, of course he is at a what? Rest position. So that is acting as a S frame. And the person who is there in the aeroplane, he is acting as a what? S dash frame. Because the aeroplane will be what? Flying in the sky, isn't it? It is under the motion. So we are taking it as S dash frame. Now another bird is there which is there in the what? Space. Now we both are observing that bird. According to me, the position is different, and according to that person, the position will be different. So now we are finding the position of that body with respect to S as well as with respect to what? S dash. Now let's talk about this position according to the S frame. As it is there with how much distance? Is it the X dash value? So now its position is X dash because it is there at a X dash distance from the X axis, isn't it? So the distance becomes X dash. So this is the X dash coordinate. And is it the Y dash? So this is the what? Y dash distance, and this will be the what? Z dash distance we will take. So X dash, Y dash and Z dash be the coordinates of the event P according to the S frame. It is according to the what? S frame. But when we saw the same event according to S frame, the coordinates will change. How will be the coordinates? It is X, Y and Z will be the coordinates. Now, this point is there at a certain distance from the S frame also, okay? And what will be the that distance? Is nothing but equal to X. So, shall I consider that is the X value, that is the X distance. So, from here to what? Here. The distance becomes what? X. And from this frame to this one, the distance becomes what? X dash. That is what the thing. Now, according to this, how much distance it is covered? Y. According to the second frame also Y dash. Means y is equal to y dash can we take? Because there is no change along the y-axis. Only the changes is happening along the what? X-axis. Y-axis remains the constant only. And at the same time, the z-axis is also remains constant. So the z value also not changing. Only the x value are going to change. So according to the x frame, the distance of the event P is x meter, and according to the x dash frame, the distance of the event P is equal to how much? X dash meter. That is what the thing. Now, how to convert this equation? If we know the x dash value, how to take x value, or if we know the x value, how to take the x dash value. So that transformation equation is coming by the what? Galilean. So we are calling it as what? Galilean transformation equation. So let's talk about that. Now, as the x distance is from the S frame to the point P, so the total distance becomes x. Now that is equal to from here to here distance plus from here to here distance. Is it equal to the addition of these two distances? This is the first distance and this is the second distance. So when we add these two, we are getting the total distance, which is nothing but equal to x. Now first we should calculate this distance. What will be the distance? So we know one formula of the velocity. Velocity is equal to distance traveled divided by time. V is equal to d by t. Now we want to find this distance. And this frame is moving with how much velocity? V velocity at a time is equal to t second. Then what will be this distance? T is equal to. So is it nothing but equal to V into t? Can we take from this formula? No. We got this distance as well as this distance. So we are adding these two. So when we will add these two, what we will get? X dash plus d value. D value is nothing but equal to Vt. So can we take x is equal to x dash plus Vt? That is nothing but the total distance of a event P according to the S frame. Only according to the what? S frame. So this is the x value. Now coming to the y. Is there any changes is happening along the y-axis? No any changes. Means according to S frame, how much distance it is there? According to the S dash frame is also there with the same distance along the y-axis. That's why we are taking y is equal to what? Y dash. And the next along the z-axis, no any changes along the z-axis. So how much distance along z is there? Same distance is there along the z-axis at the S dash frame also. So we are taking z is equal to what? Z dash, isn't it? So only x value will change, but y value and z value will be what? Remains the constant quantity. And once again we will talk about the time. So as something event is happening, for S dash frame it will take certain time. For S frame it will take certain time. But both the times remain same. As I am doing this video here, the video will take 20 seconds or 25 seconds. According to me also it is 25 seconds. According to you also it is 25 seconds. Means the time taken to happen this event for both the frame of reference remains the constant quantity. According to the what? Galilean. According to Galilean, both are taking the what? Same time to happen the event. So when both the observers are seeing the event, according to both of us, it will take the what? Same time. That's why T is equal to T dash we will take, isn't it? Now, if you convert this, how it will be? In terms of x dash, so is it nothing but equal to x dash is equal to x minus Vt. In terms of x dash frame, I am giving. So x dash is equal to, you got the value, y dash is equal to y, z dash is equal to z, and t dash is equal to t. And whatever we got in these equations, these are called as what? Galilean transformation equation. They are calling it as what? Galilean transformation. Because he transformed the equation there. Because suppose if you know the distance of the event P according to S frame, but according to S dash frame, if you doesn't know, then also you can calculate by using this formula. Because here x value you know the velocity of the x dash frame and how much time it taken to reach that point. So if you know all these quantities according to S dash frame, what will be the distance? So we can calculate. That is what x dash means. What? Say what I am observing. That example again I will take. So I am observing the bird. According to me, I will calculate the distance of that bird from me. Let it be what? X. As the bird is, this aeroplane is moving with certain velocity. We know the velocity of the aeroplane as well as how much time it had taken to reach that space. So if I know all these things, according to the observer who is sitting in the aeroplane, and how much distance is there that bird from that observer, we can calculate if you know these things, isn't it? So that is what the conclusion of this transformation equation. So that transformation equations we got here. So these are called as what? Galilean transformation equation. So let's talk about, if you talk about the Galilean transformation, we are drawing two frame of reference. One is S, another one is S dash. S is at rest position, S dash is moving with the velocity how much? Feet. It is moving with the uniform velocity. Means it is comes under which frame of reference? Yeah, it is coming under what? Inertial frame of reference. Both are comes under the what? Inertial frame, because it is at rest and it is at uniform velocity. Now, as it is moving, its velocity is v, and how much time it had taken? T seconds. So we drawn that, and something event is happening at the position P, and according to S frame, its position coordinates are x, y, z. According to S dash, its position coordinates are how much? X dash, y dash, and z dash. Now, x dash is nothing but how much distance is there from the x axis. That is x dash with respect to S dash frame, and x means how much distance that event is there from the what? S frame. That is equal to x distance. Now we are moving to the what? Transformation equation. Means if we have one equation, one value, if you know how to calculate the another value with respect to the another frame. So to have that, we know x distance. The total distance is equal to the addition of this distance plus this distance. Already we know this distance is equal to x dash, and this distance we will calculate by the what? Velocity formula. Velocity is equal to distance traveled divided by what? Time. Now this is v into t. The distance becomes v into t, and this is x dash. So we are adding these two. So x is equal to, you got the equation. But as it is moving along only y-axis, so there is no change along the y-axis and the what? Z-axis. That's why there remains the what? Constant. And also to happen that event, the time is not changing according to both the frames. So the time also remains what? The constant quantity. Now if you transfer this with respect to the S dash frame, we will get the equation like this. So these are called as what? Galilean transformation equation. So from this you can calculate the what? Other things. Now second thing I am telling here, if the same frame, if it is moving along the y-axis, let's imagine that the same frame, it is not moving like this, it is moving along the y-axis. So that time, what would we get the equation? What we might have get the equation? That is nothing but y dash value changes there. That time, if it is moving along the y-axis, so that time the equation becomes x dash is equal to x, isn't it? And y dash will be y minus vt. Z dash value remains constant, and time is also remains constant, isn't it? In the same way, if it is moving along the z direction, that time z value changes. This is what the thing. In which coordinates it is moving, no? That coordinate value changes, and other quantities becomes what? Remains constant, isn't it? So this is what about the Galilean transformation equation. So in the next class, we are starting the first concept of your syllabus, that is Michelson-Morley experiment. So that one we will see in the what? Next class. Thank you.